Charlie, you're still in the way.
All right. Good afternoon. The due date for the project is Tuesday, December 12th, 3 p.m. So if your group has not finalized the project yet with me, you should do it as soon as possible. So I'm asking, when you want to submit your project, you should bring the project, the physical, the mechanical mechanism that you have designed and you have built. Just bring it to my office. SolidWorks file on flash drive. You bring the flash drive. I just put it on the desktop, and you can get your flash drive back. And also, you should record 1 minute, up to 1 minute video from explaining what your project is doing and showing the mechanism is running. So I just posted some samples of the videos that the students recorded last year. Yes?
Are we going to present something when we bring that project?
No presentation.
Just bring it and
just bring these 3 things.
Is there a due date for a draft or anything?
The due date, what I want to see is we finalize the project. It's already past due, but you can do it by next Wednesday if you have not finalized yet.
Just what we want to do, or?
Yes, what you want to do, but you come and talk with me. If I need to do any revise or something like that, I'll do that, and we can start doing that.
So do you want like a SolidWorks file, or
when?
For exactly next Wednesday?
No, just you are telling me that our group is going to design this, and that mechanism is going to generate this design task. If it's a function generation, you give me this is the desired task that you would like to generate. If it's a motion generation, I posted some samples of the project that if you are interested in that, you can go with one of them. It's going to be on the canvas. Record the video up to 1 minute, and printing is taking time. So I sent you email with the email address of the gym who is running the step lab. So you should schedule a time with him after you are done with your design and you finalize your project. You schedule the time with him, then he's gonna put you in line and send. You are gonna give him your SolidWorks file. He's gonna upload it on 3D printer, and the machine is gonna start printing the parts. I'm suggesting that, I'm recommending that you finish your project as soon as possible, because if you wait until the last week of the classes, then you may not have enough time to print out the parts. Because everybody is going to be busy on that week. So it's not only our class, some other classes are using that printer. So it's going to be live. Any question on this? So I'm not accepting any project after that. Tuesday. All right. Let's continue on function generation. For the offset slider crack. Suppose you would like to design a slider crank with an offset such that it generates this desired cast. 1, 2, 3, theta I and SI. When it's at angle of 20 degree, we would like S1 is at 1.8 inch, and when it's at 50 degree, we would like this at 2.8. 110 degree, we would like this be at 5.3. So we would like to generate this desired task. If I look at this task, it's a correlation between input link angle and the output link position, which is S. So it's a function generation. And it's a 3 precision points because we provided 3 desired or 3 precision location. So in same as 4-bar mechanism, you might be given by, instead of having this, you might be given by theta 1, 2, which is theta 2 minus theta 1, equals to 50 minus 20, 50 minus 20, 50 minus 20, 30 degree. You would like S12, which is S2 minus S1, 2.8 minus 1.8, be at 1 inch, and theta 1, 3, theta 3 minus theta 1, 110 minus 20, 90 degree, S13, meaning S3 minus S1, 5.3 minus 1.8, which is 2, 3.5, yes, 3.5. So we don't have this, we might be given by this set of desired task, and we would like to generate or to synthesize the mechanism such that it generates this desired task for us. So the governing equation is the vector loop equation. We form the loops, we form the vectors, and then we form the vector loops. The vector loop equation will be A cosine of theta equals to S plus B cosine of phi. And for the Y component, it's going to be sine. S1 plus B cosine of P1. For the first precision point, S would be S1, theta would be theta 1, and phi would be phi1. For the Y component, it's going to be A sine of theta 1. It doesn't have any Y component. It's going to be C plus B sine of phi1. second precision point, when the mechanism is moving from angle of theta 1 to angle of theta 2, the location of the slider would be S2, and angle of phi is going to change to phi 2. But C is not going to change. C is the constant. It's the length of, it's an offset. So we are going to rewrite this equation again by changing theta 1 and phi 1 to theta 2 and phi 2. Same thing for equation for third precision point. Now, I would like to write all angles with respect to first precision point. So A cosine of theta 2, I'm going to write theta 1 plus theta 1 2 equals to S2. I'm going to write it as a S12, S1 plus S12 plus B cosine of phi 1 plus phi 1 2. So theta 2 would be theta 2 would be theta 1 plus theta 1 2. So A sine of theta 1 plus theta 1 2 equals to C plus B sine of phi 1 plus phi 1 2. And third precision point, A cosine of theta 1 plus theta 1 3, S1 plus S1 3 plus B cosine of phi 1 plus phi 1 3. And A sine of theta 1 so we get 6 equations by writing all angles with respect to first precision point. Now, if you look at these 6 equations, what should be their unknowns? What would be the unknowns here? Work on this. Then I come. Number 2. Number 35. Okay, what do you think?
Okay, then ones, A, B, C, theta 1, phi 1, S1, And then your free choices are 5, 1, 2, and 5, 1, 3.
And just unknowns for now. What else? That's it?
That's it.
And number 31. Yep.
So noise, the data,
So say it again.
the data,
Okay. Which data? The angles have index, so theta 1, theta 1, 2.
the one, yeah.
What I'm asking is in this equation, system of equation, which is 6 equation, which terms are unknown? So this is going to be theta I, bi, and pi. So you just should look at this 6 equation and see which terms which terms are unknowns.
So except the one is already right?
Except
So the ISR, the ISR and ISI.
yes. So you said theta. Which theta? We have theta 1, theta 1, 2, and theta 1, 3.
State 1, 3.
Is unknown. Okay. What else? Is a noun? You should do it this way. You should look at each term,
Yeah,
starting
which
from
is
here,
what?
to see and determine if it's a noun or unknown.
This one is unknown.
Okay, A, C, and B are the length of or the size of the mechanism that we want to design. So for sure, these are the unknown terms. So A, B, and C. So theta 1, we don't know where is the location of link 1 at the first precision point. This information doesn't provide theta 1. So theta 1 will be unknown. S1 meaning the location of slider at first precision point. This information doesn't provide that data. So S1 would be unknown. B, I already counted here. Phi1, what is this angle at the first precision point? We don't know, so Phi1 would be is S1, I counted that, A, theta 1, C is here, Phi1, A, theta 1, I counted, theta 1, 2 is given, S1, I have, S1, 2 is given, 1 inch, B is unknown, Phi1, I counted that, Phi1, 2 is unknown. Phi1, 2, I don't know how much would be the angle of Phi1, 2.
So the value knows that's there.
Say it again.
So that's unknown, right? For 3, 1,
Yes, these are unknowns. I just rewrote these things here. But this one is not complete because it doesn't have Phi1, 2 and Phi1, 3. So we have 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 unknowns.
We can make 2 free choices. Right?
We have to. This is after we figuring out the unknowns, we count them. There are 8, but 6 equation cannot solve for 8. 2 of them should be picked as a free choices. We pick Phi1, 2 and Phi1, 3. So free choices would be Phi1, 3 and Phi1, 2 as noun. So you pick the values, and we solve for A, B, C, theta 1, and Phi1. Make sense? Question on this. Alright. The rest is just next slide is going to solve this system equation, same as four-bar mechanism. I'm using some intermediate variable. So P would be A cosine of theta 1, Q would be A sine of theta 1. T, I use B cosine of P1 and U as a B sine of P1. So if I expand this term, it's going to be A cosine of theta 1 cosine of theta 1 2 cosine of this times cosine of this minus A sine of theta 1 sine of theta 1 2. The B term B cosine of Phi1 cosine of Phi1 2 minus B sine of Phi1 sine of Phi1 2. This term. I expanded this term. If I expand this term, it's going to be A sine of theta 1 cosine of theta 1 2 minus plus A cosine of theta 1 sine of theta 1 2. So I'm gonna rewrite this sixth equation as a term of P, Q, T, U, S1, S1 and C. So unknowns. P, Q, T, U, S1 and C. So here unknowns were A, B, C, theta 1, P1, and S1. These are free choices. So now instead of having this unknown, I'm going to have P, Q, T, and U plus S1 and C. So let me rewrite this system equation. I can explain over the slides. So first equation, A cosine of theta 1 is P, right hand side would be S1, B cosine of P1 is T. So S1 plus T. Second equation, A sine of theta 1 is Q equals to C plus B sine of P1, which is U. C plus U. Third equation, it's going to be A cosine of theta 1 plus theta 1 2. The first term is this, which is P. This term, sine of theta, is Q. So it's going to be P cosine of theta 1 minus Q sine of theta 1 2. P cosine of theta 1 2 minus Q sine of theta 1 plus, now equals to C S1 plus S12 plus B cosine of Phi1 plus Phi2. I expanded this, it's going to be P, and this is going to be Q. P cosine of Phi1 2 or T. It's a Phi1, sorry. T and U. T cosine of P12 minus U sine of P12. This is a question 3. You can write the question 4, 5, and 6 in this form. Any question on this? So now I'm gonna rewrite this system of equation in a matrix form. The variables are P, Q, T, U, S1, and C. I'm just writing here. P, Q, T, U, S1, and C. So here it's going to be P, Q, T, U, S1, and C. So first equation, which is this, I should move it to the left side. P minus S1 minus T equals to 0. So the coefficient of P is 1, and the coefficient of S1 is -1, and coefficient of T is -1 as well. The other terms, they get the coefficient of 0. 0, 0 for U, -1 for S1, and 0 for C. Second equation, I'm going to move this to the left side. Q minus U minus C equals to 0. P is going to be 0, Q is going to be 1, T is 0, U is -1, this is 0 and -1. And third equation, this is unknown, this is unknown, this is known, this is unknown. So the right hand side of third equation is S12 positive, which is known. It was 1 inch in this example. Coefficient of P is cosine of theta 12. Coefficient of Q is negative sine of theta 12. T is this guy. If I move it to the left side, it's gonna get sine of negative. So negative cosine of P12. C P12 meaning cosine of P12. The coefficient of U is positive sine of P12. Coefficient of S1 is -1, and there is no C on the third equation. Row 4, it's gonna be sine of theta 12, cosine of theta 12. T is negative sine of P12, and U is negative cosine of P12. S1 doesn't show up, and C has a coefficient of -1, and no constant. Row 5, cosine of theta 1, 3, negative sine of theta 1, 3, t, negative cosine of phi 1, 3, and u has negative cosine of positive side. Positive sine. P1, 3. We have S1 with the negative 1. S1, 3 is on the right hand side. And coefficient of C is 0. And last row is gonna be sine of theta 1, 3, cosine of theta 1, 3, negative C, B, negative sine, negative sine of P 1, 3, and positive cosine of P 1, 3. S1 doesn't show up, and C is 1, there is no constant. So if we get 6 by 6 matrix on A, this is the variables that we are looking for, and the constant one. If you look at this matrix, it looks different than the other one. Why we got different matrix here? Why it's gonna look like different? Exactly, because the unknowns, it should be some font right here. Here the unknowns are PQ, over there I have PQ, TU, S1C. Here we have PQ, S1C, TU. So the way that you order the unknowns, it's going to tell you how this matrix, the coefficient matrix, is going to look like. But at the end of process, you will get the same result for PQ, S1C, TN. So you might start with U, T, PQ, S1C. This matrix is going to be different. This is going to change, but at the end you will get the same result for PQ, S1, PQ, TU, S1, and C. So now, when you solve for unknown, you will find P, Q, T, U1, S1, and C. But you are looking for A, B, and C. So what are the P and Q? A cosine of theta 1, A sine of theta 1. Same as 4-bar mechanism. A would be S square root of P squared plus Q squared. If you square them and add them up, you will get A squared cosine squared plus A squared sine squared. If you add them up, you will get A squared. If you apply a square root, you will get A. Similarly for B. B will be a square root of T squared plus U squared. This is A, this is B, C coming directly from solving the this system equation. And S1 is coming from this. I'm looking for theta 1 and phi 1. Theta 1, you should look at these two equations. P is known, A is known, to solve for cosine of theta 1. You will get two angles here. Sine of theta 1 would be Q divided by A. You will get two angles there. Find the matching pair. Do the same things for phi 1. Cosine of phi 1 is T divided by B, T divided by B. And sine of phi 1 is U divided by B. So two angles here, two angles there, find the matching pair. So then you can draw the mechanism at first precision point, and if you were asked to draw at the second and the third precision point, you can do that because theta 1, 2 and phi 1, 2, theta 1, 2 and S1, 2 are given. So I ask you on problem number 4 to draw the mechanism at its first precision point. So for the MATLAB part, you are gonna solve this and find A, B, theta 1 and phi 1, but for drawing you don't need to submit it by MATLAB. You can draw it by drafting instruments. So problem 4, just the first part should be submitted by the MATLAB. For drawing part, you should draw it by using drafting instruments. Question on this. Alright. The next topic is still function generation for a 4-bar mechanism. We already covered function generation for 4-bar mechanism, but here we are going to look at a different method. And on next slide, you will see why do we need sometimes a different method.
Question?
Yes.
So the analytical method already takes care of having a timing ratio that's not equal to.
Yes. Okay. Suppose we have active stairway and this ladder needs a mechanism such that when this link, this is going to be a 4-bar mechanism, one joint here, one joint here, the mechanism should have one joint there and one joint on the ladder. When this mechanism is moving by this angle, which is 24, the ladder should be open by 30 degrees. So theta 1, 2 is 24 degrees, phi 1, 2 should be 30 degrees. We would like to generate this. And when it goes from here, when it's open by 40 degrees, we would like this opening by 60 degrees. So we have covered this problem, but what we would like to know is when you design this mechanism at first precision point, when it's at this angle, this is the first precision point, we would like phi 1 be at 180 degrees. So phi 1 we would like to be 180 degrees when the mechanism is at the starting position. So what should we do? This is a 4-bar mechanism, function generation. We pick beta 1, 2 and beta 1, 3 as free choices. We solve for A, B, C, theta 1, phi 1, and beta 1. Solve. So free choices are beta 1, 2, and beta 1, 2. So with free choices, you will find A, B, C, theta 1, phi 1, and beta 1 such that it generates this desired task. So we basically find phi 1 as well. You check with the desired phi 1. If it's not 180 degree, you should back to change the free choices. But it's very difficult to find the free choices such that it generates the angle of phi 1 equals to 180. It's a time-consuming process, and since you have no control over phi 1, you should try and error to find the desired beta 1 and beta 2 such that it generates phi 1 equals to 180. So to avoid this difficulty, we introduce this method. So instead of picking free choices as a beta 1, 2 and beta 1, 3, I move this to the unknowns part and pick theta 1 and phi 1 as a free choices. So still I have 6 unknown, 1, 2, 3, 4, 5, 6. But in this case, my free choices are theta 1 and phi 1. And simply here I can say phi 1 must be 180, and whatever is desired for theta 1, I provide this angle. Although this angle is not important for us, this the orientation of the ladder at the starting point is what we are looking for. So we look at this method when the input, the orientation of input link and output link is desired at the beginning of the process. So let me draw. So the problem has not changed. Still we are generating a desired function, but the free choices has been changed from beta 1 to beta 1, 3 to theta 1 and phi 1. So you remember when we did the displacement analysis, we looked at the point with 2 arrows ending together and write the vector loop about this point. So it's going to be A cosine of theta plus B cosine of beta equals to D plus C cosine of phi, and sine y component is going to be A sine of theta plus B sine of beta equals to C sine of phi. So on displacement analysis, we derive these two equations. So on displacement analysis, theta was given. We are solving for theta 3 and theta 4, which is beta and phi. Here, we would like to get rid of beta. We would like to get rid of beta. I'm going to keep it here, move the other terms to the other side. I squared both sides. So B cosine of beta equals to D minus A cosine of theta plus C cosine of phi. And B sine of beta equals to C sine of phi minus A sine of theta. We have done this before. To get rid of one of the unknowns, we squared both sides, add them up. left side is gonna be b squared, because b squared cosine square of beta plus b squared sine square of beta is gonna be 0. Right hand side is gonna be this d, which is 1 plus c cosine of phi minus a cosine of theta square plus the second parenthesis, which has been squared, plus this one. We have done this before, so, and I'm just escaping the steps. Here, b cosine of theta 3, instead of theta 3 we have beta. Theta 4 is phi, we squared them both sides. We add them up. We did some simplification and we could get this equation, and at the end we end up to this equation, k1 cosine of theta 4, which is phi, minus k2 cosine of theta 2, which is theta here, plus k3 equals to this part, cosine of theta 2 cosine of theta 4 plus sine of theta 2 sine of theta 4 is cosine of theta 2 minus theta 4. If I expand this, I'm going to get the right hand side. So on right side, I'm going to write cosine of theta 2 is theta and theta 4 is phi. And k1 is d over a, which is 1 over a. K2 is d over c, which is 1 over c. And k3 is 1 square plus c square plus a square minus b square divided by 2ac. This is where that this method is gonna stop. So I'm gonna continue on Wednesday class. So we have exam on next Monday. I'm not gonna be on the exam. My TA is gonna be there for the exam. So it's a closed book. You are allowed to bring one sheet, four-sided. Don't forget the calculator. And what else? It's going to be on Science Center. 1 to 47.
You posted like the stuff like that?
I posted.
Is it like it doesn't go out with because they keep your website.
Yeah. And post.
Yes.
Velocity acceleration and post. There are two questions on the exam.